Okay, so let's move on to the next topic, which is the cost of electricity. The cost of electricity. This includes tariff structure also. In the group activity, you have already done the meter readings and how energy bills are calculated. So generic guidelines will be given in this lecture, and we will define fixed and variable costs or operating costs separately so that you will get an idea. So in cost of electricity, we'll first see what is fixed cost and what is operating cost. Operating cost. So what are the components of fixed cost? Fixed cost comprises of the depreciation charges, then depreciation charges mean it can be against buildings, dams, turbines, generators, circuit breakers, transformers, transmission lines, or any other equipment used in the production, transmission, and distribution of electrical energy. These investments represent huge sums, right? Maybe in millions of dollars or billions of dollars it would be. So after some time, after the usage has started, then it will have depreciation. So depreciation charges have to be included. Now coming to operating costs, it includes salaries paid to the employees. Then it includes fuel costs. So these are basically variable costs. For every unit of energy that is produced, there is fuel consumption associated with it. So fuel costs are to be included in this component. Then administration, then other daily and weekly expenses. All those things are comprised in operating costs. So fixed cost and operating costs. Now, keeping these two cost components in mind, the utility defines his electricity price, right? So the electricity is consumed by the consumers. How much the utility should charge the consumers for the consumption of electricity, that is defined or that is arrived at based on these two components of costs. So in general, we can say that the rates of energy, the rates paid for energy are based on, one is amount of energy consumed. So what should be the unit here? Here it should be kilowatt hours, right? Then second is the demand itself, the demand. So demand means the rate at which the energy is consumed. So it is in kilowatts. This is in kilowatt hours. This is in kilowatts. Okay. Sorry. Now, the third one is the power factor of the load. The power factor of the load. We know that for industries, they have big machineries which consumes reactive power for production of the magnetic field. So the effective energy that is consumed by the industry would be more if their power factor is less. Less than unity. So in that case, it will reflect on the energy bills. So sometimes for big consumers, big in terms of capacity, okay, for big consumers, we include power factor also as a component. Now, the tariff, the first component is tariff based on energy, right? This one, tariff based on energy. So this is this depends upon the amount of energy consumed in kilowatt hours. But however, I mean, if a consumer uses no energy at all, if he is not consuming any energy, still he or she has to pay a minimum service charge because the cost incurred for keeping him or her connected to the line, that is paid by the utility or the owner of the infrastructure. So he has to pay that service cost. Now let's see the tariff based on kilowatts. So that is about tariff based on kilowatt hour. Now tariff based on kilowatt. For tariff based on kilowatts, we will see some examples through examples we'll demonstrate it. I'll show you a figure and based on that we'll see. Let's see. Just 1 second. Okay. So I'm stopping. I hope you can see this figure. Then see the monthly cost of electricity supplied to a large customer. It depends not only on the energy consumed, but also upon the rate at which it is used, or based on kilowatts also, as we have seen. Not only on kilowatt hours, it depends on kilowatts also. So the cost also depends upon the active power. Kilowatts means active power drawn from the line, right? Drawn from the line. So let's see how this is calculated based on this example where we have two factories, factory A and factory B, and the power versus time plot for both the factories are shown here. You can see for factory A, it is almost constant, but it's fluctuating, but it's not that fluctuating, the power values, and it is drawn for 30 days. For factory B also, the power plot is drawn for 30 days, but it's highly fluctuating. But each of these spikes are not lasting for a long time. It's for a short period of time. So if kilowatts do not last for a long time, then kilowatt hour consumption would be less. So this does not mean that always they have a high energy bill, or they have to pay a very high energy bill. So that depends on the time frame also, the time frame during which it is calculated. So that is also very important, how the demand meter is set, for what time period the demand meter is set, that is also important. Now let's see the factory A operates at full load. Here factory A is operating at full load day and night. It includes Saturdays and Sundays, and it's constantly drawing 1000 kilowatts of active power. And at the end of the month, it's 720 hours, right? 24 into 30, 720 hours. So if I want to find the energy consumed, what should I do? I should multiply this 1000 kilowatts with 720 hours. Then I'll get 7,20,000 kilowatt hours of energy. So that is a consumption for factory A. Now coming to factory B, what happens is it's not uniform, right? It has many spikes. It consumes the same amount of energy. You can see the total energy that is consumed is 7,20,000 kilowatt hours, which is same as factory A. But the demand or the rate at which it is consumed is different. So based on energy only, if you charge the bills, then both these factories are having the same electricity bills. So that is a disadvantage with that system. So that is why we are going for three components. One is kilowatt hours, another is kilowatts, and another is power factor. Three things we are using, especially for industries. We use the third component, power factor. That is very significant. Now here you can see the power fluctuates between some 50 kilowatts to some 3000 kilowatts. That is a fluctuation range. So the capacity of transformer and transmission line supplying this factory B, should be greater than that supplying the factory A, right? Because it might have already hit the limits if the capacity is low. With respect to factory B, it might have already hit the limits. So it depends on many factors. The electric utility must therefore invest more capital to service factory B compared to factory A. So that is the importance of these components, kilowatts, kilowatt hours, and power factor in the calculation of electricity bills. Now let's go to the next topic, which is demand meter. Let me stop sharing this. Again, I'll go to the next one. Demand meter. So what is demand meter? Demand meter. What is demand meter? See, I'll show the. See, we have already seen the spikes corresponding to high power drawn by motors for factory B. For factory B, we had seen fluctuations are there, many spikes are there. That may be because of the machines installed, the starting current of the, the high power drawn by the motors during starting time. Now the high startup power does not last long enough to warrant the installation of correspondingly large equipment by the utility company. So how long does the power surge have to last? So if it is not a long duration high power if the high power consumption is not for a long duration, then it may not affect the higher energy consumption, right? So how long we should wait for calculating the average power consumption? What should be the duration considered? This depends on several factors. The period is usually taken to be 10 or 15 or 30 minutes. If the high power lasts for 10 or 15 or 30 minutes, then if the bill is calculated for every 30 minutes or 15 minutes, then this will be accounted. The high power consumption would be accounted. Normally for large power users like industries or municipalities, the averaging period it can be as long as 60 minutes. This is called the demand interval, at which the demand meter calculates the average demand. Because every instant it is not possible to find the power demand. It should be for a time period. And what should be the time period? That is a question now. Okay, so demand meter and demand interval. Demand interval. Okay, these two are the terms. Now, don't worry, we'll do some problems so you'll get a better idea. That is why I'm not writing anything here. Now, the average power measured during each interval is called demand. And the interval at which it is measured is known as the demand interval. Okay, so as time goes by, the meter records the demand at every demand interval. If it is 15 minutes, then every demand interval it's calculating it. And the pointer moves up and down in a calibrated scale as the demand changes. So in order to record the maximum demand, the meter carries a second pointer. So two pointers are there for a demand meter. Two pointers, one like this from this point, another like this. Okay, so first one calculates the demand, second one calculates the maximum demand. Maximum demand. Okay, so to record the maximum demand, the meter carries a second pointer that is pushed upscale by the first, right? The first one is moving, always moving, but whenever we see a maximum demand, this will move. Okay, the second pointer simply sits at a position the highest position in the interval. Highest position in the sense the highest value of power consumption at that particular interval. At the end of the month, a utility employee takes the maximum demand reading and resets the pointer to 0. The maximum demand pointer will be reset to 0. If the demand is calculated for a month, or the bill is calculated for a month, the maximum demand in a month is known from the second pointer. This one, the second pointer. The first pointer will show the demand itself. Okay. Now, after that month's bill is, after noting that month's bill, it is reset to 0. Then it will again go for the next month and it will find the maximum power point, maximum power consumption point. So this special meter is called a demand meter. So demand meter has two pointers. One points to the demand itself and the second one is for the maximum demand. Okay, this is normally used for industries and commercial establishments. This meter is used for industries and commercial establishments.